Hi, everyone. My name is Aurelio Muraca. I am the technology program coordinator with the Danbury Library. And again, on behalf of the Friends of the Danbury Library, we welcome you to episode 2 of Earth in Crisis. And tonight is Antarctica. It ain't what it used to be with Professor Mitch Wagener of the biology department over at Western Connecticut State University. And once again, Mitch, thank you for being with us tonight. And lo and behold, you may begin.
All right. Well, I always start with this slide. Some of you who are familiar with WestCon will recognize the science building. When I first got here, which was 1996, by the way, I've been here 30 years now. The patch of land where this science building is now was the football field. So if you are a WestCon alum that was around prior to 2005 or so, you may remember it that way. Anyway, that's the story on that. Let me begin with a confession. And where are we? The fact confession is that I've never been to Antarctica, although I know quite a bit about it because I'm a climate change educator. I spend a lot of time and a lot of effort to try to explain the difficulties and the complexities of climate change to both undergraduate students and the general public. And occasionally I get invited into high schools to talk to high school students, mostly by high school teachers who are my former students. The advantage of being around forever is you tend to know people. And although I do not have, I've never set eyes on Antarctica, I have lived in Alaska for 14 years. So I can assure you that I do know what minus 60 feels like. I have changed my oil in outdoors at minus 20, and that is no fun at all. I could tell you stories, but that's probably for a different talk. Well, we have an Earth, our only home, and a biosphere that is thin. Not doesn't seem thin to us because we're ants crawling around on the surface, but thin in the sense of the size of the Earth itself. The biosphere is defined as that portion of the Earth's surface and below the Earth's surface in the oceans and up in the atmosphere that can and does support life. Okay. The biosphere is all we got to live in. Keep this in mind. We may at some point establish permanent settlements on places like Mars. There are problems with that. Maybe that would be a subject of a good talk in the future. Why Mars is going to be a tough place to live. But for right now, we've got a perfectly lovely planet. And if we don't muck it up, we have a place where we can live and our children and grandchildren and even little dogs like Ringo can live. So anyway, um, the poles of the Earth are those points around which the Earth rotates. One of the quirky things about Earth is it was knocked off on a angle by an early collision in the early Earth. There was a object about the size of Mars that slammed into the Earth back when Earth was still pretty hot, back when the solar system was young. And that did a couple of things. One is that object, which is scientists call Theia, was consumed within the Earth because the Earth was semi-liquid and remains there still. The force of the collision knocked a couple of chunks of Earth off in the opposite direction, as planetary collisions will. And those chunks came together, coalesced into what we call the moon, Luna. So Luna is made up of Earth stuff. And we know that because we've been there, we've collected samples, and we can analyze it chemically, and it is of the same origins as the surface of the Earth. The upshot of this is that the collision also knocked the Earth on an angle relative to the sun, but it's not a constant angle. It's wobbling back and forth. And there's a wobble to the Earth caused by the by Theia being inside. Plus, the orbit of the Earth is tugged on by the large planets out in the outer solar system. And so the orbit of the Earth around the sun is not a circle. It's not a it is an ellipse. And the ellipse is always changing parameters because of the gravity tugging. Anyway, uh, and that all of those things make Earth a variable environment, which is quite habitable for humans and for life in general. Could there be life on other planets? We don't know. There might be. I mean, in our solar system, there certainly is somewhere. Just as Mr. Obama said, just the odds of it are too likely. Anyway, and so our Earth is odd, and it spins, and as it spins, the air moves in a way that is affected by the spin, the Coriolis effect, and the circles around which the Earth spins, the points of spin, are the poles, and um, they are they get light from the sun, but the light is coming in at a high angle relative to the surface, and so the light is spread out and has a relatively low effect on heating the surface. And so the Earth at the North Pole and the Earth at the South Pole are cold as you know what. And I can tell you all about Alaska. I've never been to the North Pole, although I've been as far north as Prudhoe Bay in the summertime. But it is bloody cold at certain times in the winter, and Antarctica is even cooler. Now, Antarctica is cooler in part because it's surrounded by an ocean. Two differences I want to contrast I want to make between the North Pole and the South Pole before we get looking closer to Antarctica. One is that the North Pole, if you were to go to the geographical North Pole, the place where the Earth is spinning around that spot, um, and drill a hole down through the ice, you would hit water far before you would hit any kind of land surface. Okay. So that means that when the ice of the North Pole is exposed to, well, let's put it this way. When the oceans are warming as they are, that ice is subject to the warming of the water underneath it and the warming of the sun during the northern polar summer as well. Okay, so the ice of the North Pole is under a double warming, and the ice is getting thinner, and it is becoming less a smaller area as time goes on. And at some point, um, the children of the future. I always thought that I could say that my grandson sometime in his life would be able to paddle a canoe to the North Pole during the summer, and it may happen earlier than that because the ice sheet in the north is floating. Now, Antarctica on the other side is a continental ice sheet. The it's that continent, which is, and I'll show you a a view of what it looks like under the ice if you were to like lift up the ice and look underneath. It's continental masses that have come together, and we're not always at the South Pole. And there are mountains, and there's volcanoes, and there's subnivean lakes that are underneath the ice, and all that kind of stuff. And so it is colder by nature because it is sitting up at higher elevation. It's not, except for at the edges, it's not in contact with the water. Okay, so there we have it. The South Pole is going to be colder than the North Pole, although it is rich with life, at least around the edges. Now, the context for what I'm going to be talking about, of course, is the context of the world in which we live, and that is one that is warming. So we have glaciers that are melting, even in Antarctica. There is snow cover melting. There is spring coming earlier. There's sea ice melting, and ocean heat is going up, which means the water is taking up more space and sea levels rising and all that stuff. Okay. And so, this lovely, it's a really nice little illustration that kind of hits the high spots of what's happening in in response to the warming of the environment. Some are warming, some are increasing in quality, quantity, some are decreasing. Okay. And life is responding to it. So as the world warms and spring is coming earlier, migratory animals are migrating in earlier. Okay. Which may or may not help, and flowers are blooming at a different time, and that sometimes there's kind of a mismatch between when the flowers are blooming and when the bees are there to pollinate them. Okay, so there's a lot of problems that it causes when the world is warming like it is. All right. And Ripple, scientist named Ripple, and his, I assume it's a him, maybe it's a woman, I don't know. And colleagues have put together three graphs where they actually collect the data showing those arrows and more. So if you're interested in this data, email me, and Mario's or Aurelio is welcome to share my email address, my university email address, and I'll send you the papers if you want to look at them. Okay. It's all scary as hell and illustrative of much of the things I talk about when I'm talking about this stuff. Now, another thing that's changeable about the Earth is the fact that the plates that are formed from volcanic activity and the fact that Earth is hot underneath us through leftover heat from the formation of the Earth, that the plates that we happen to live on move around. Okay. They're not the earth and the continents that we know were not here back during the Jurassic or even during the Pleistocene in the same way. Okay. Back in life's history in the past, um, because of the nature of things, these plates were in different locations to a larger or smaller degree, depending on how far you want to go back. And these plates are interacting with each other. Okay. So there is a big line of volcanoes and an area underneath the Atlantic Ocean, north to south, and that separates and matches, it's kind of equal distance roughly between the New World and the Old World. And that is where new plate is formed. That's one place. Okay. And those volcanoes are erupting, and the plates are spreading out away from that, and pushing the part of the plates which are above sea level and cool enough to be solid ground are what we live on, what we're familiar with, and they're moving in whatever direction they're moving. Okay. There's other areas where one plate is sliding underneath the other one. It's called a subduction zone and being consumed and becoming part of the mantle again. And then there's others where the plates are moving relative to each other, and as they rub, they have friction, as they do occasionally, they will have earthquakes. That's the fault in California. That's what caused the 1906 earthquake in San Francisco and tremblers they've had ever since. And so there's all that stuff going on. And there are places in the world that are hot spots. Alaska, especially, the southern coast of Alaska are hot spots for this stuff. And we felt earthquakes fairly frequently and, relatively small ones that would shake the dishes and stuff. And occasionally a volcano would erupt and so on. So the upshot of it is the way things are now isn't the way it always was. And so these continents have moved around a fair bit. And the process by which it does is the fact that the mantle underneath the surface is hot because the farther you go down, the hotter it gets. And that heat that is down there is residual heat from when the Earth was young. It's old heat. It hasn't cooled off yet. And because it does, the rock and stuff is semi-liquid, and if it's denser than the surrounding rock, it'll sink, and if it's less dense, it rises and so you get convection currents going in the rock. They're really slow, but they still are, are active, and you can see the results of them. And also occasionally some of these convection currents will form like a little what's called a hot spot, where really hot rock from down farther below comes up to the surface, and as the plate slides over the top, they'll occasionally erupt, forming a volcano such as we have in Hawaii. The whole Hawaiian Islands are a chain of these things. That the northwest most islands are the oldest ones, and the volcanoes there are the least active, and they're pretty cool. I mean, they're cool. The rocks are cooler relatively, whereas the Big Island is the new one that erupts periodically. And eventually there'll be another one sprout up to the southeast. And there's a bunch of these weird things around, like super volcanoes that'll erupt sometimes and cause massive effects to life and so on. And Yellowstone is one of those we can look forward to erupting at some point. Anyway, so all this happening, the Earth is not living in that fashion in as an organism, but it's living in terms of being active and moving around. All right. Now, Antarctica. Antarctica is a continent that is now at the South Pole. It is a large area. Has some really high elevation. It has volcanoes. It has all sorts of things. It has lots and lots of ice and snow and glaciers and all that stuff, and it's bloody cold. And around the edges is abundant life fed by the life in the ocean. Penguins live on land part-time, but they eat what's in the ocean. There's no bugs or anything like that to eat. I think the smallest land animal on the continent of Antarctica is a tardigrade, or a tiny little wingless insect called a columbella, and are found in McMurdo valleys, and they're flea size, and that's as big as the terrestrial organisms get there. But there's big ones offshore, and the whales and whatnot. Now, back in the way back, you can see to the eastern side of the middle of this graph, mostly between the equator and 30 degrees north, is a large chunk of what is now Antarctica. Okay. There are fossils of forests in Antarctica. And there probably were dinosaurs on the continent of Antarctica, when it was in a different location than it is now. Everything is in a different place. And so at this time, Antarctica was kind of stuck up against between Australia and India, which were separate, and Laurentia, which is kind of the northeast segment of North America plus Greenland. Okay. Then gradually through that process of the drifting continents, the plates moved in ways that you know, that they do, and Antarctica drifted and migrated, and not purposely or anything. It's just the way luck would have it, took it to the South Pole. Okay, where any big life, was not allowed to, or not able to survive. And such is the case with all sorts of other things. If it looks like South America and Africa could fit together hand in glove, it's because they were together at one time. And there's a family of fishes that is found on both continents, and different species, but the same family. And there's no really good reason why they should be found on both continents that are so far away. It's a fascinating topic of Earth history and all this, and where things were when, and ice ages and all that stuff. India, by the way, didn't become a part of Asia until much later, and it basically was through these processes pushed against the bottom of the belly of Asia, and in the force of the collision in India crashing into the rest of Asia, crumpled up a bunch of the rocks forming the Himalayas. That's why, and that happened relatively recently as far as geology goes. And that's why those are the highest mountains on Earth now. All right. If we look at Antarctica from above, hopefully you can read the letters on here. There's labels that show a few things. You can see just slightly above the middle is a dot, and then it says the South Pole. That is the geographical South Pole of of uh, of the Earth. You can stand on it. In fact, there's a big scientific facility there, and some person put a barber pole, which I'll show you a picture of later on, right at the pole. So you can, if you're there, you can go stand there and have your picture taken at the South Pole. Okay. It would be an expensive trip for one picture, but nonetheless. Um, and it is a place of active scientific research. The Russians have a station over called Vostok, which literally means east. Now, one of the big quandaries about Antarctica is that if you're talking about the South Pole, which way is north? Well, everywhere is north. Everywhere is northward of the South Pole. Okay, but which way is east and which way is west? Well, there is a peninsula at the top of the screen that's called the Antarctic Peninsula, which is also called the banana belt of Antarctica because it's warmer than the rest because it's surrounded by ocean and it's warmed somewhat by the oceans. And some of the ice melting has happened faster there than in others. Anyway, that little peninsula uh, is pointing at Tierra del Fuego, the southern end of South America, and perhaps was connected at some point. I don't know that. I'm just guessing. And so that would be your reference to Antarctica, which way South America and us too, North America, would be if you took a line from the South Pole through the Antarctic Peninsula and kept going, it would go through the Americas. Okay. Now, informally, there is a portion of Antarctica, the larger chunk, which is East Antarctica, and the smaller chunk is West Antarctica. Probably because those are the chunks that are in the Eastern Hemisphere and Western Hemisphere. If you look at it a little smaller, you can see the Antarctic Peninsula that way, pointing at South America. Now, you also see that there are mountains. You also see that there are areas that look near the coast that look fairly flat. And those are ice sheets and ice shelves. And I'll explain the difference here in a bit. If you were to pick up the ice on Antarctica and look underneath it and see the topography of the land below it without ice, this is kind of what it would look like. It would be a series of islands here, with some bigger islands on what's the left here, and also some lakes underneath the snow. And we'll talk about one of those later on. It's Lake Vostok, and what we know about it and what might be there and what might not. But it is high elevation. It is a true continent and islands on the edge and so on. You wouldn't necessarily infer that just from looking at a picture of the Antarctic continent itself as it is now. And so this graphic is kind of the same, although it gives you a little bit better idea of the relief in terms of high areas to low areas than the other one did. And you can see that there are some pretty high areas, but they're of course covered with snow. And you only see them quote unquote with ground penetrating radar. And if the world were to melt sufficiently that the ice on Antarctica would be gone too, it would look kind of like this. Not the colors, those are indicating elevation. Now, the ice that's on top of that landmass is arranged into more or less discrete ice sheets. Okay. These are sheets that are defined by which way they're moving. Ice, like the water it is, flows downhill. Now, liquid water will flow quickly. Ice flows slowly because it's got, it's cold and the water molecules move slowly because of that relatively, and it has tight cohesion, but not cohesion is not the right word, but attraction between the water molecules that hold it together and make it react slowly. So an ice cube, you could sit there with an ice cube and try to bend it and it wouldn't bend. You might break it, but you won't bend it. Okay. And so, but over long geological times, the ice and so on will move, and it moves downhill, pulled by gravity, just like water flows downhill. And so when it reaches the ocean, it will often extend out over the water. And eventually it will lose contact with the bottom so that there's water below this ice and air above the ice. And at that point, it's not an ice sheet, it's an ice shelf. And that's the definition. And will continue to move out, and it will be eroded more rapidly from below because the water has thermal mass that melts the ice, and the air above it, although it's bloody cold, is still going to, and the sunlight will melt some of it too, and it'll chunk off pieces that will become icebergs. Greenland has the same thing. Greenland is a much smaller body, and if you were to peek under the ice, it would be an archipelago, and there'd be a big lake in the middle of it because the ice has compressed the stone down. So in the middle is below sea level. Anyway, Greenland might be another topic for a future talk as well. Anyway. Most of these things are moving slowly. Now, One generality I can make is that Eastern Antarctica, because it is higher in elevation and not in contact with water except from the edges, is colder than Western Antarctica is. Western Antarctica is um, more of it. It's lower in elevations on average, although there are some mountains and so on and volcanoes. But there is more ice that is in contact with water, and so it is more fragile in that way. Okay. There are a couple of island or a couple of ice sheets that are particularly of concern these days, and you may have heard the names because they are showing signs of breaking up. And one of them, they're all on the west side here. If you see the word west in West Antarctica and you go to the coast, you'll see one called Thwaites, the Thwaites Glacier and the Pine Island Glacier to just up the coast a little bit from it. Those two are kind of the canaries in the coal mine here. When they go, which they will, maybe not in our lifetime, but they will at some point. But the thing is, we don't really know, um, much about the timing because weird things can happen and there may be cracks and stuff we don't know. And if they go, then sea level will rise. Well, I'll give you an estimate later on. All right. And so this illustration of the same thing basically makes it easier to see those areas which are ice shelves, which mean that underneath the ice was more water. And the other non-ice shelf is underneath the ice is land. Um, and the ice shelves are the ones that are more fragile in terms of chances of chunking off into the ocean and so on. Uh, on the Antarctic Peninsula, there is the Larsen ice sheet, and there with the Larsen A and the Larsen B and Larsen C toward the end of the peninsula. And I'll show you that one of those at least has totally disappeared. If you look at the mass change in gigatons over just the last 30 years for this data, you can see that in Greenland's here and by for contrast, it's the blue one, and it is warming up fastest and losing the mass the highest or the fastest, and that's because it is in an area where it collects dust on the surface of the area on the surface of the ice, which lowers the albedo, its reflectivity, and makes the ice melt faster. And it's more of it is suspended up above the ocean a bit. Anyway, so Greenland's melting fast. If we were to be so foolish, in my mind anyway, as to try to mine Greenland in a large way, the ice has to go somewhere, and that would raise sea level several feet, and that would not be good for any of us. Um, East Antarctica, which is the colder part, is losing the least amount of ice. That's the yellow one. West Antarctica is kind of intermediate between East Antarctica and Greenland, and the chartreuse, the kind of pinky purple, there is the average of all of it. And then the Antarctic Peninsula has already lost most of the ice that it was easy to melt, and so it's fairly stable at this point. So you can see Thwaites Glacier there. By the way, McMurdo is a location of one of the scientific facilities that's, I think, permanently manned down there on the edge of the Ross ice sheet. And the Thwaites, it is an ice sheet that is got a bottleneck between mountains, and that is the point of uncertainty here about how fast the Thwaites ice sheet is disappearing. And, it's beautiful. Ice floating on a blue sea is spectacular. I've only seen pictures, but I would certainly love to to see it in person, although I don't know that I will. And this is looking down from a aircraft, and you can see a chunk of that breaking off the main part of the ice sheet and getting ready to go on its own way. When it detaches from the main glacier and becomes its own iceberg, then it will sink lower in the water, it'll float lower in the water, and it will contribute significantly to sea level rise. And there are scientific vessels, icebreakers, that go down and collect data and do all sorts of stuff. It's really important to study in a warming world to study the Arctic regions and the glacial regions, including Greenland and including the alpine tops of mountains and so on. If you look at Mount Kilimanjaro and right near the equator, the highest mountain in Africa, used to have a lot of snow up there, and Hemingway wrote a short story about it, or a short novel about it. And well, that was the setting. Um, and now there's hardly any snow at all up there. Just it's warming up. All right. And so the area that is in orange is to a greater or lesser extent losing mass of ice. From the edges, those areas that happen to be blue are gaining mass. The net balance of mass is for a loss. In fact, this graph basically illustrates that. So those ice sheets have names, and they are identified by a three-letter code. Um, and the circle shows the mass of the ice, and the color indicates whether it is a mass is a lot, it's losing mass year by year or gaining mass year by year. There are a few spots in eastern Antarctica that are gaining mass, but not many. And the ones in the west definitely swamp, the mass balance of comparison of the two. And we can see our Pine Island Glacier, and we can see Waits Glacier there, and a number of other ones. And when the ice moves to the point where it loses contact with the bottom below and becomes a shelf, and then loses, it basically melts to the point where the rest of it falls into the ocean. It makes a sound that is totally indescribable. It is, I I have seen glaciers calving into the Copper River in Alaska in a much smaller scale than this. And it is a phenomenal sound. I don't think there's any concert speakers in the world that could produce that kind of bass. Well, and there are scientists all over the place trying to get a handle on how which glaciers, which ice sheets are more or less stable, and the stability is defined as the amount of ice moving toward the ocean is is a negative, or it's not going fast. And so it's a stable one. Whereas those that are retreating have the wetted edge of the ice sheet pulling back every year. And there's all sorts of ways, the scientists have ways of studying these. And in fact, there was researchers on Thwaites Glacier this southern spring or northern summer or southern spring or fall up here that has a drilling rig where they put a temperature sensor through the ice to get an idea of what the temperature of the water was underneath because there's volcanic activity down there too. And if you have a volcano that's warming up the water underneath the ice, that's going to make that ice melt faster. And that kind of information is necessary for figuring out how fast these things are breaking up if they are. And so you have an ice sheet that moves out where it loses contact with the bottom that it's setting on. It's called the grounding line. And from there to the end, it's a shelf because there's water below it. And it's vulnerable to chunking off and forming icebergs and stuff. So, Thwaites Glacier, and this is a relatively small ice sheet as things go. If Thwaites were to collapse entirely, global sea levels would increase by 2 feet. Now, 2 feet if you live in Denver or Edmonton or, in the Alps, doesn't seem like very much. But if you happen to live in southern Florida or Louisiana or Bangladesh, that's a catastrophe beyond imagining. Thwaites contributes a 40 some percent to the all global sea level rise at the moment. I think that's what that says is behind. So think about all the people that are living near the edge, literally and metaphorically, living near the edge of continents where they are feet or inches above sea level, and imagine what 2 feet of sea level rise would do to them. 2 feet of sea level rise that happens relatively rapidly. You would have climate refugees in numbers that can't we can hardly imagine, and human suffering in a level we can't imagine either. Think about, massive floods and the Dust Bowl all happening at the same time times 100. I'm just not pull that number out of my head, but it would be awful. So climate change is everything change. One of these events happens, which it will happen in our lifetimes. It will affect not only what's going on in Antarctica, but it will affect Bangladesh. It will affect London. It will affect Back Bay of Boston. It'll affect Florida. It'll affect New Orleans. It will affect Rio de Janeiro. It'll affect Alexandria. It'll affect Bangkok, where I used to live when I was a kid. It'll affect, you know, Hanoi and Ho Chi Minh City, Saigon, and oh, so many places. Now, um, Antarctica is a place where studying biology, and it has its own particular peculiar biota. In the above ground, above ice, you've got all those flightless seabirds, the penguins, and occasionally a sea lion will flop up on the line. They have other birds and things like that going on. But underneath the ice, you have um, Antarctic krill, you've got crustaceans of various kinds and fishes and whole food webs that rely on them. Um, Antarctica is kept colder than the North Pole because of this current that is zipping around it that keeps it isolated from much of the warm water that's coming in from the, you know, from the warmer areas. I think we've already talked about that. There are some hardy souls or fools, depending how you look at it, that like to ice climb, and they will climb the edge of these ice sheets. It sounds like that's not a very clever thing to do because these ice sheets are unstable. but they're photogenic. Larson B, that's the one that broke up in the last 30 years or so. It's about the size of Rhode Island. And Antarctica is got plenty of researchers, analyzing and collecting and looking at everything. Also, it's also got on the eastern or on the western side, it's got subnivean volcanoes. Volcanoes are underneath the ice. We know that they're there because we can see the evidence of past eruptions. If they were to erupt, and it's hard to predict when, if they were to erupt, it would be a good chance that an awful lot of that ice would uh, would shag off into the ocean, and you would have a fairly catastrophic sea level rise. And we can see the evidence of past eruptions from ground penetrating radar. Now, one other thing is that if you looked at the topography underneath the ice, you would find watersheds. You would find river valleys. You would find lakes. And there is a particular lake called Lake Vostok. It's a Russian word that means east because it's in East Antarctica, I think. And it is way long ways below the ice. We'll never go swimming there or water skiing there, even if you wanted to. It's about there. The the photograph in surrounded by green, the big one, shows the depression of the lake shows up at the surface, so you can see the outlines of that lake. It's about the size of, it's the largest subglacial lake in Antarctica. It's 4,000 meters below the ice surface, same size as Lake Ontario. It's freshwater, and it was discovered only in 1976. Its temperature is -3, and it remains liquid because of the pressure of the ice above it. It's and geothermal heat below. It is supersaturated with oxygen. It has more oxygen than a surface lake by a factor of 50. There are bacteria in nearby ice, but we have not put a probe in the lake itself because by doing so, we would be contaminating the lake, perhaps. We don't want to do that. And it also has 1 to 2 centimeter tides, if you want to know. One of the quirky things. And we knew all this because scientists at the Vostok, the Russian station, have drilled down near to the lake and took samples and inferred a lot of this. And here is what happens if you are a comedian and you're at the South Pole. This is what the South Pole looks like. And you can, I can't hear your laughter, so I'm hoping you're laughing. Um, here is the South Polar Station, and the pole in question is right there. And when you stand at the geographic South Pole, all the lines of longitude converge at that exact point. So you're literally standing in all 24 time zones at the same time. You can step from today into yesterday and back in tomorrow. It's the only place on Earth you can time travel, such as it is. There's also sea ice around Antarctica that ebbs and flows with the seasons and is as it's receding gradually because of the warming of the oceans, and which you could see in this graph. And there is all sorts of problems with the larger animals, penguins, emperor penguins that are extinct in some areas, and the Arctic krill, which let's see, have decreased in number. Lower pregnancy rates in humpback whales and so on. So scientists are down there figuring all that out. Now, as luck would have it, there are other polar ice sheets in the solar system, not just in Earth. There is a water ice northern ice cap in Mars and a CO2 ice southern ice cap on Mars, if you're interested. And there you go. I would be happy to try to answer your questions.
If you have any questions, please put them in the comments. Thank you so much for this presentation. It was really, really great.
Thank you.
So if you're interested in asking a question to Professor Wagener, please do so. I was wondering, what would be like the first instances of like catastrophic, change resulting from the ice sheets melting in Antarctica? Like, what would be an educated guess?
Well, there's been some research done to suggest that adding a bunch of land-based ice to the Antarctic Ocean there, Antarctica would first raise sea levels in the northern hemisphere, and in areas around Greenland would actually have a rise of sea level first from a kind of a teeter-totter effect, which I didn't see coming, but that is something that is speculated about. We won't know till it happens, but it's quite possible that that could be. And so, people not much closer than we lived in Antarctica would feel the effect first. Although with satellites all the way around and all the research scientists and stuff down there will know ahead of time that it's coming. It will eventually, as the ice increases, it will be a high tide that does not leave.
Wow, that's not good.
Yeah. Oh, there was someone had down here in the chat. Am I let's see. First one is Mulata saying hi. Hi, Mulata is one of my former students. Many coastal cities have, and this is Bill, many coastal cities have subways. Oh, geez. Are any cities preparing for sea level rise to prevent flooding of the subways? And perhaps some of them are. Indonesia is in the process of building a new capital on Borneo instead of Java because Jakarta is likely to be flooded out at some point. Thailand should do the same thing, but there are so many historic buildings and so much tourism in Bangkok, they can't give it up. There, whatever work is being done in that way is insufficient. The people who make the decisions and who have the power to spend the money and all that stuff are insufficiently terrified about this stuff. Maybe they think they've got more pressing things that have to be done in the short term. Perhaps they think it'll all happen after they're gone. But for those of us who have grandchildren, we have to think about the world that they will inherit.
Well, also, what are the geopolitical implications if this starts to happen, especially towards Thailand and Sri Lanka and all those places?
Yeah. No, I mean, already you have island nations in the Pacific. Kiribati is one of them, where the World War II Battle of Tarawa was fought. That is gradually being abandoned because it's a few feet above sea level, and they're losing their ability to feed themselves. And so the government bought land, maybe in Australia, and I think some in Fiji, and they're gradually starting to move people away. imagine losing your country. Not just taken over by bad guys, but it's gone and uninhabitable. Think about that. So yeah, there's some there are some things which are of great concern. And we're not taking it near seriously enough. Okay, what's the next one? Oh, and far as subways go, oh man, I don't think coastal cities will be able to have subways. They may be able to have monorails or something, you know, but Bangkok, I think, has a subway now. And they also have elevated trains. I haven't been there in a long time, but just from what I've heard. How far north would the big ice sheet go when it breaks off? It depends on the currents and winds and how fast it melts and all that stuff. Would that ice make it up to South America? Maybe some of it would. The ice of Greenland is a lot closer to human habitation than Antarctica is, and so we already see some of that. I mean, the iceberg that sunk the Titanic back in 1912 came off a ice sheet in Greenland. And that's before they had sonar and radar and all that other stuff. So yeah, I don't know. Let's see, what's the projected time frame for the loss of the ice that you mentioned? It all depends. There are events which are basically random. They're not really random because we're only random to our perceptions because we don't understand all the causes and stuff. A volcano erupting under West Antarctica isn't random from a geophysical point of view because it's all the results of things that are happened that I've even talked about. Um, but random in terms of human perceptions, it you know it could happen tomorrow. It could happen when my grandson's my age. It's hard to know. How lucky do you feel? How lucky do I feel for my grandkids? Uh, Now it's a little better that in that scientists have instruments on ice sheets that are in danger, which can be read by satellite and can detect movement. If you have two that are a certain distance apart and one of them is more dangerous, more in danger than the other, and they start moving apart as determined by the satellite, readings, then you know something's happening. Um, it's scary. Let's see. Oh, and the rest of them were very kind. Thank yous. Any other questions that I can answer?
Yeah, if there's any other questions, please let us know. If not, oh yeah, when do the mosquitoes start to disappear in Fairbanks? What month?
Let's see. There's snow in Fair. We lived in Fairbanks for 14 years, and I remember temperatures as cold as minus 60, minus 65. And it's no fun at all driving in that. And you have ice fog and all that stuff. You generally have snow on the ground from mid-October to mid-April. And the mosquitoes come out, I think it's in June maybe, and will disappear about the time the first frost hit, which in some places is August. They're not around very long, but most of their life cycle takes place as larvae in little ponds and stuff. They're a pest. There's also black flies up there too.
Awesome. Thank you, everyone. Thank you so much for joining us this evening. Just be sure to register next month. And oh yeah, yeah. And
What's
then
the next one?
the next one is, hold on a second. Let me go ahead and try to see this.
I have it on my calendar too, but I don't remember.
Yeah. So hold on a second. Let me just go ahead and see. Sorry, I don't have the calendar right in front of me. Let me just call it up, and I can let you know. So the next one will be March 12th. Episode
Okay.
3, Alaska Ecosystems.
Oh, there we go. Yeah, you'd be able to answer some of these questions will come up again. And
Excellent. Yeah.
yeah,
So
no, Alaska is a very varied ecosystem, all the way from, Seattle almost to, Greenland. So there's lots to talk about.
excellent. So we'll see you all then next month. And until then, I bid you a great evening and watch out for that storm that we have going on
Mm.
this weekend. So be well. We'll see you next
All
time.
right.
Bye.
Bye, everybody. Bye, Relio.
Bye.